Let's do some thermal energy question. For those of you in IGCSE, this is in chapter 2. For those of you in SPM, this is in your chapter 4, form 4. Recall there's only two heat energy equations. One is Q equals mc theta. The other one is Q equals ml. Alright, the top one, that's the specific, that one uses the specific heat C. The bottom one uses the specific latent heat. Okay, so you must be able to tell both the difference between both of them and when to use them. I strongly advise, once again, if you're not familiar with these two equations, do not attempt this worksheet first. Alright, go back and revise your notes first. Alright, these two equations, you need to be familiar with them before we can continue using them. Alright, let's take a look at question 1. Okay, question 1 says that calculate the amount of heat that is needed to heat water of mass 10 kg from 30 Celsius to its boiling point. So what's the boiling point of water? It's 100 Celsius, 30 Celsius. So the information given is specific capacity of water is 4,200 joules. So this is a bit obvious. So this question wants you to use the first equation, since they already given you the specific heat capacity. Alright, so let's write down the equation first. Q equals mc theta. Recall, Q is heat energy. Okay, it's energy, so it's in joules. M is mass in kilograms or in SI unit. Theta is in degrees Celsius, is the change from highest temperature to lowest temperature. And C is specific heat capacity. That's the complicated one that all of you don't like. That's joules per kilogram per Celsius. So after I plug in everything, okay, I need to find the amount of heat energy. That means Q. Alright, what is Q? So very simple. Mass 10 kilograms of water, that's a lot of water. Alright, and C 4,200 joules per kilogram. And theta, right? Theta, this is the one that a lot of you get it wrong, or you're not sure which one to minus. Is it 30 minus 100 or 100 minus 30? So always remember, take the bigger one minus the smaller one. It doesn't matter which one comes first, whether you're boiling or you're cooling, always take the bigger minus the smaller one. Okay, of course it's not so simple as that, but for your level, just assume take the bigger minus the smaller one. So 10 minus, plug into your calculator, 10 times 4,200 times 70, and you get, that's a lot of energy, 240,000 joules. Alright, so if we were to simplify to joules, I can simplify it to 2.94 megajoules. Okay, so I hope you know how to change this to using this prefix. Alright, let's take a look at another question, this time question 2. Alright, so this question is very interesting. Alright, it doesn't give you any energy, however it gives you power. Alright, it says that an immersion heater is rated at 1,500 watts. Calculate the time taken for water of 5 kilograms to reach its boiling point if the initial temperature is 28 Celsius. So we are bringing water from 28 Celsius to 100 Celsius. Alright, and we're supplying 1,500 watts of power. Okay, so a lot of you, if you have forgotten from your chapter 1, alright, you've forgotten, this is where in exam you're panicking, oh no, where's the energy? You know, the energy is not given. Record from chapter 1, alright, or chapter 2 for those of you in SPM. Power is equal to work over time. Alright, remember, work is just energy. Alright, or power is equals to Q over time. It's the same thing. Alright, work, energy, same thing. Alright, so in this case, so if the equation, let's write out again, since we need specific capacity, since there's a change in temperature. Remember, latent heat, there's no change in temperature. Since there's this change in temperature here, so it's definitely a specific heat capacity question, and because they gave us specific heat constant. Alright, so Q equals mc theta. Okay, so what is Q? Q is not given. Mass M. What is mass? Mass is given as 5 kilograms here. C is 4,200. Alright, theta is 100 minus Celsius, 28 Celsius. All right, again, just take bigger minus smaller. All right, Q. All right, we don't have Q, but we have power. So what do we do? What we can do is Q equals to power times time. How I did that was I just take this time and I multiply it with power. I just bring it up here, and what you get is PT. So if I rewrite this, it just becomes 1500 T. Okay, let's solve the right hand side first to simplify it. Okay, so again, another big number, 152,000. If you're wondering why the number is so big, it's because this is a lot of water, 5 kilograms, and the previous question was 10 kilograms. All right, so what I'm going to do is just solve for T, 15 divided by 1500, and I'll get 1008 seconds. All right, it takes quite a long time to boil this water. Okay, that's how you do specific heat capacity question.